Okay, today's notes, more graphing. That's it. There's two examples. I'm going to tell you very clearly, I will do the first example with you. You are going to do the second example. On your homework tonight and on your quiz, this is exactly how it will be laid out. So you will know everything that you are being asked to find. So, let's get started. Domain. Domain comes when you set the denominator equal to 0. So in this case, x squared minus 9 equals 0. I need to solve that. That factors to x minus 3 and x plus 3. So I get values of 3 and negative 3. The thing to remember with the domain is that the denominator is not allowed to be 0. So our domain then, x is all real numbers except 3 and negative 3. So x can be any number at once except for 3 and negative 3. What else comes from setting the denominator equal to 0? The vertical asymptote. Yeah, that's how we get the vertical asymptote as well, is setting the denominator equal to 0. So we have two vertical asymptotes in this case. X equals 3 and x equals negative 3. I told you this before, but I'm going to say it again. If you do not write x equals, I'm not giving you credit. So if you write equals 3, you don't get credit. It has to be x equals 3, x equals negative 3. So I'm going to graph those just because I have them now. Okay. Next up on the list is holes. Holes occur if something cancels out. That would be something that canceled out of both the numerator and the denominator. Our denominator factored, our numerator didn't. Nothing canceled out then. What that tells us is that there are no holes. Yes, a hole will occur if something cancels out of both the numerator and the denominator.
Oh, okay, so it's like if it's like x squared plus 9, then that would be a hole.
So if instead, let's say we were looking at something like this, and our denominator, we factored it and we got this. Okay, these cancel out, that would give us a hole. Yeah, you can. Good question. Definitely can have multiple holes. It's not very frequent, but yes, you can. X and y-intercept. We've talked about these. X-intercept means that y is 0. This is what we just did in our warm-up. So I'm going to set y equal to 0. If we put that as 0 over 1, we can cross multiply. So we get 0 equals x squared. We take a square root. Square root of 0 is just 0. So you can have multiple x-intercepts. In our case, we only have one. It's the point 0, 0. This is something we have not seen in our notes before, so I want us to pay attention to this. That x squared, the way that we got 0 was an even degree, or a multiplicity of 2. That's very important. The fact that this 0 had a multiplicity of 2 tells us that this x-intercept is going to bounce. It's like when we did our zeros before. The multiplicity tells us we're going to bounce. Okay, next up, y-intercept rather means that x is 0. I kind of ran out of room, so I'm just going to do it in my head. If I plug 0 in, I get 0 over negative 9. 0 over negative 9 is just 0. So this doesn't happen often, but this is the rare case where the x and y-intercepts are the same. 0, 0, that's the origin.
How would you tell if the y-intercept bounces or not? Just
It's not going to. Or it's not one that we're concerned about.
Oh.
Only the x. You cannot eat in here. Okay. Next up, horizontal asymptote. This is when you compare the degrees. In this case, we have x squared and x squared. Since those are the same, we divide the numbers out in front. So 1x squared and 1x squared gives us y equals 1. Again, it has to be written as y equals 1. Just 1, I'm not going to give you credit for. Y equals 1. So I'm going to dash that in. And then the last one, it says new. This is not actually new to us, though. We want to know, does our graph cross the horizontal asymptote? So in this case, you are going to set the horizontal asymptote equal to your equation. So my horizontal asymptote is 1. My equation is x squared over x squared minus 9. If we put this over 1, we can cross multiply. So I get x squared minus 9 is equal to x squared. X squareds cancel. So I get negative 9 equals 0. That is a false statement. That tells us we do not cross the horizontal asymptote. Do not cross the horizontal asymptote. Whew. At this point, we have enough information to finish the graph. Always start wherever you have any points. In this case, we only have one point, the origin. Here's what your thought process should be. From the origin, when I go left, am I going up or down? When I go right, am I going up or down? Well, we just figured out we cannot cross the horizontal asymptote. So it is not possible for us to go up in either direction. That would cross the horizontal asymptote. What we have to do is go down. And remember, as a check, that x-intercept was supposed to bounce. We said that that x-intercept was going to bounce. And it did. Came up and bounced, it didn't go straight through. You with me so far? Okay, now we have to figure out what is happening on either the left side and the right side. So we have two more parts of the graph to do. Before we do that, we have to look at our vertical asymptotes. So that's what we're going to do next. When we look at our vertical asymptotes, which came from here, from our denominator set equal to 0, remember we have to consider their multiplicity. A first power and another first power tells us in both cases we will be going different directions. We cannot be going the same direction. If
it was even,
it was even, they'd be going in the same direction. So in this case, if I go to the left side, here I'm going down. If I'm going in a different direction, then it means I can't be going down again. So I can't be going down and down again. That means on the left side of that asymptote, I have to be going up. And then remember we talked about we cannot cross that horizontal asymptote, which means we have to come down like this. Right side, similar idea. I have to be going different directions. If I'm going down here, I can't be going down again. So if I can't be going down, I have to be going up. I cannot cross the horizontal asymptote, so I come down and hug it. And that is the graph. questions before you do one? Okay, that takes you through step by step by step. You need to use a similar idea on the next one. Before you start this second one, or I guess while you're starting it right now, I want to help you. We have to remember to factor the denominator. So let's make sure that we do that. How is the denominator going to factor? X plus 2 and x plus 2. You're going to want to write that, though, as x plus 2 squared. Okay. You have 10 minutes with your group right now to finish this problem. So what I'm going to do in a minute is show you all of the information on the left side. I have not graphed, though. So here is what you should have gotten for domain through crossing. And then you should have been able to graph the intercept, the crossing of the horizontal asymptote, and the two asymptotes. And it looked like, when I was walking around, that for the most part, we were successful on this. There are two things that we need to note before we graph. With our x-intercept, that x squared again, a multiplicity of 2, that x-intercept is going to bounce. So that is something that we're going to have to keep in mind when we graph. Our x-intercept is going to bounce. Our vertical asymptote from the denominator has a multiplicity of 2. That's even. So our graph is going to go in the same direction on both sides of the asymptote. So either both are going to go up or both are going to go down. Are there any questions on what I've come up with so far before we complete the graph? Okay. Christian?
For when you cross a horizontal asymptote, how did you find the y? Did you
It's
just
always
plug in?
It's always going to be the actual horizontal asymptote.
Okay.
Okay. Starting with the 2 points that we have. It makes the most sense if we were to start at the origin to go up. Right? If we start at this other point, we're not going to come down and go back around. That doesn't make sense. So what we do know is our graph is going to start like this. Now here is the trickiest part, is figuring out the rest of what goes on over here. The first thing I want us to note is to remember that that x-intercept is going to bounce. So we are not coming down here. We are going to bounce. So it's going to bounce up like this. Then we have to decide, we know we're going to hug the asymptote. Are we hugging the asymptote below or above? Well, we're not allowed to cross the horizontal asymptote again. We already crossed it the only one time it crosses. So that means that our graph is going to come up and hug below the horizontal asymptote. Because we can't cross the horizontal asymptote again. Now, we need to do the left side of the graph. It says same direction. If I'm going up on the other side then, I need to be going up as well. So then remember, we can't cross the horizontal asymptote again, so we're just going to come down and hug it.
In the beginning, how do you know the first line was going up?
Based on the 2 points that we were given.
Okay.
So it doesn't make sense to come down and back like that, so it has to go up. Any questions for me?
So if it was if the AH was -1, 2, you'd be able to cross the HA twice.
Can you repeat that question again, please?
Yeah, like if it was if the cross AA or HA was -1, 2, able to cross that line twice?
If there was more than one point, you could cross it however many points you come up with.
Okay.
So what might end up happening is when you solve this equation, you might end up with a quadratic instead. Like x squared equals 4.
Yeah.
That would have two solutions. Two solutions for x would give you two different